Welcome to this video where we're going to have a look at the minor planet Quaoar and its ring system that's been discovered around it. Now it's a particularly unusual ring system because it relates to the Roche limit and where it lies in respect to that, which is unusual in comparison to other ring systems that we know about. So before we go any further, I just want to recap on the ring systems that we already know about. So Saturn is probably the most obvious planet we know about that has rings. You can see these in your back garden. They're quite easy to see. They have very obvious, easy to spot rings, quite dense, quite large. So they're not particularly rare ring systems in the solar system. Saturn is the most obvious ones, and you can see they look quite beautiful. But also some of the other planets have ring systems as well. So Jupiter has fairly faint rings. You can't really see them particularly very well, but this is them kind of edge on. So they've got quite thin rings, quite diffuse rings, but they are there. Neptune also has ring systems as well. And again, you can see them with the James Webb Telescope on the right. You can see them quite thin, narrow rings. Again, they're not particularly very prominent like Saturn's rings. Saturn is a little bit unique in how spectacular and dense they actually are. So Neptune has them, Jupiter has them as well. You also have Uranus. So Uranus also has thin ring systems as well and some moons orbiting there. So all of the outer planets have got ring systems orbiting them as well as a significant population of moons as well. And it's not just planets actually. There are other minor planets, asteroids, those sort of things that are in the outer parts of the solar system, kind of where Pluto is, so beyond Neptune and that also have ring systems as well. So again, it's not just planets that we know can have rings. Minor planets and asteroids can also have rings. So again, rings are not particularly rare. So why is this particular one a little bit unusual? Well, this one, the actual configuration of it is we have the minor planet in the centre. We then have the ring around it. We then also have this moon orbiting around the outside of the ring called Quaoar. So you've got the ring and then this moon around the outside. Again, that in itself is not particularly unusual. Now, where does it actually sit? Well, it sits in the same sort of location as Pluto in the Kuiper belt. So it's beyond Neptune in its orbit and distance from the Sun. So it would be known as like a trans-Neptunian object. It sits in that disk of material pretty much around where Pluto is and all the other minor planets in the Kuiper belt. So it sits in that sort of location, a long way from the Sun really actually, in more the outer parts of the solar system, so beyond the planets. Now, the thing that makes it unusual is its location to the Roche limit. So the Roche limit is inside the ring as opposed to the other way around. So things like Saturn's rings and that, they're configured the other way around. So this Roche limit is inside and then you have the ring system on the outside. That is particularly unusual. Why is it unusual? Well, let's have a recap of the Roche limit and what it actually means. Well, it's a distance from the planet when a smaller object like a moon or a satellite would basically be tidally pulled apart by the planet. So if you get too close, it starts to be tidally stretched, and then at some point, which is the Roche limit, it can't hold on to itself, it can't gravitationally hold itself together against those tides that are trying to stretch it and pull it apart. So at that point it actually gets disintegrated and pulled apart. So that's the Roche limit. If you get too close to a planet, then the tides actually pull it apart. On the other way, if you were to have ring material that was inside the Roche limit and it moved outwards, or any material that was on the outside, that could gravitationally collapse into a moon. So it could grow into a moon because the gravitational tides from that planet are less, or they're low enough that the gravitational forces can actually allow it to grow into a moon basically. So if it's beyond the Roche limit, you would expect moons to grow from like a ring. Inside, you wouldn't expect moons to be forming because they would continually be pulled apart. The gravitational forces wouldn't allow it to grow into a moon. So that's the distinction really for this Roche limit, and then the relation to the rings as well. Now Saturn is a really good example because the Roche limit for water ice, which we predominantly think Saturn is made of, is pretty much at the edge of the ring system. So all of the material of Saturn's rings is inside the Roche limit for water ice, which it's mostly made of. So it means that the tides inside are too strong to form moons. Now, if you've seen any of the other videos or you know a little bit about Saturn's rings, there are moons inside this, which are inside the Roche limit for water ice. But the argument there is they're probably not made from water ice. If they're made of a different material that's stronger or has a higher density, then actually the Roche limit moves in as well. So it gets closer. So it just means that those moons are likely not made of the same material that the ring might be. So ring material inside the Roche limit can't grow moons. Now, if you want to find the actual location of that, you can use this equation here. This is the distance, the Roche limit from the planet, and it relates to the radius of the planet, the density of the planet, and the density of the moon. So a more dense moon, that Roche limit would be closer to the planet. If it was less dense, then actually it would get pulled apart much further away because it wouldn't be able to hold itself together at a much more distance really. So it relates to those relative densities of the planet and the moon and the radius of the planet. Now with Saturn, again, good example, there has been cases where it looks like there may have been moons forming at the ring edge. Now the thing with Saturn's rings is it's known as viscously spreading, so they do actually spread inwards and outwards, which means they go beyond that Roche limit. Now any material that goes beyond that Roche limit could potentially then grow into a moon because the tides are then reduced enough for that to occur. So we would expect moons to form at the ring edge, specifically with Saturn, and then as that occurs, you take material away from the ring, you grow a moon, so it means that the first moon that forms there is bigger, and then the moon drifts out, it migrates outwards, then the next moon forms, and because there's less ring material there, it's smaller. So if you have a look at the architecture of some of Saturn's moons, you actually find that the bigger ones are further away, and that's because they formed from the ring and then drifted outwards beyond that Roche limit. That's why they're there in the first place. So the Roche limit is inside the ring this time round, yet it's still there. We would expect that to fairly quickly grow into a moon or form into a moon, but that hasn't been the case. It's still there. It's outside the Roche limit, so we know that should be occurring. But the other thing that's worth noting is the ring is not smooth, like I've depicted here. It's actually clumpy. So it's suggesting or highlighting that maybe that process is occurring. Maybe it's trying to actually form into a moon, but it hasn't quite got there. Well, why might that not happen? So this moon Quaoar, this orbiting around the outside, it could gravitationally be interfering with the moon forming capability of that moon, of the ring. So if the ring is actually trying to form a moon, you've got a moon orbiting around the outside, and the gravitational interactions could actually prevent it from collapsing into a moon. So that could be one plausible explanation as to what was occurring here that's preventing it from collapsing into a moon. But again, we don't really know. But the interesting thing is that it is there, and it's beyond the Roche limit, and it's not a moon. So something is preventing it from forming into a moon, and it could be that it is this moon here, or there's something else we're not quite sure of at the moment. So thank you for watching, and if you enjoy, then you can check out some of the other videos.